DAB plus angle DC to give us 180 degrees. Therefore, DAB is 180 degrees plus angle BCB is 180. Therefore, angle BCB gives us 180 degrees minus 120 because we send this 120 degrees to the other side of the equation. So we have what? Angle BCB gives us what? 60 degrees. So we have this angle to be 60 degrees. Now, it now becomes very easy for us to find what? Our variable x, because the variable x is found in the triangle DBC, and in this triangle, two of its angles have been what? Attained. Okay, so we just have to sum up all these angles and then equate it to 180 degrees. Okay, so 90 plus 60 simply gives us what? 150 degrees. So we know that x plus 150 degrees gives us what? 180 degrees. So we have x equals 180 minus 150. It gives us what? 30 degrees. So x is 30 degrees. So we are just finding the solution with the help of the properties we know in circuit theory. Okay. When you know the properties, it will not be difficult for you to be able to solve problems like this. We knew that the diameter subtends an angle at the circumference of a circle to give us 90 degrees. And we also know that when a chord subtends angles at different segments, the sum of those two angles gives us 180 degrees. So with the help of those two properties, we were able to get 90 degrees and then 60 degrees here. Because when we sum up 120 to this angle, we should get 180 degrees. Therefore, if you deduct 120 from 180, it simply gives us 60 degrees. And then we know that the sum of interior angle in the triangle gives us 180 degrees. So we summed up all the angles we have here, then we equated it to 180 degrees. 90 plus 60 degrees, we know is 150 degrees. So x plus 150 is equal to 150, which finally brings us to 30 degrees for our variable x. Okay, so question 16. We are on question 16, and we are being told to find x, which is this angle, the whole of this angle. That is BOC, angle BOC. Okay. Now, how are we going to get it? Let us try examining this diagram and see what conclusions we can draw. Okay. So, looking at this, what conclusions can we draw? We know that when we have two tangents, okay, and those two tangents are seen to be coming from a common point, then those two tangents are going to be equal. Okay. Therefore, we can say that length AC is the same as length AB. Okay. Now, when a line starts from the center and then touches the circle, okay, the circumference of the circle, it means that that line is what? A radius. So we know that this line OB is a radius, and at the same time line OC is also what? A radius. Therefore, line OB is equal to line OC. We can say that then adjacent sides are what? Equal. That is OB is equal to OC, and then CA or AC is equal to what? AB. Since this diagram, this quadrilateral, that is quadrilateral ABOC, since its adjacent sides are equal, then we can say that that quadrilateral is what? A kite. Then we can use the properties of a kite in solving this problem. Now, we know that one of the properties of a kite is that it has one of its diagonals bisecting what? The corner angles. Okay. One of it what? Diagonals bisect what? The corner angles. And this is the diagonal. That is diagonal OP is bisecting what? This corner angles. Therefore, if we have here to be 30 degrees, then it means that this part is also 30 degrees because this line OA bisects this angle completely. That's one of the properties of what? A kite. Therefore, we have here to do what? 30 degrees. We also have another property of what? In circuit theory, we say that a radius meets a tangent and it makes 90 degrees at the circumference of the circle. Okay. So this radius is making what? An angle of 90 degrees with the what? With the tangent. So we have this one to be 90 degrees. Now the sum of interior angle in the quadrilateral is what? Is 360 degrees. Therefore, since we have 90 and 90 here, we already have what? 180 degrees. So the rest of the angles will should sum up to also give us what? 180 degrees, so that we get to a 360. Therefore, we have here as what? 60. We have this angle as well. 60. Therefore, 60 plus x should give us 180 degrees. We have x equals 180 degrees minus 60 degrees, which gives us what? 150. So this x we have here gives us 120 degrees.
Action.
Okay. So we are on question 17 and that's where we are continuing from. Okay. As you know, we are told to find the variable x here. In the other question, our variable x was here, but this one it is rather what? Located at what? A, C. Now, how are we going to get this variable? We know already that when two tangents are said to be coming from a common point, two tangents of a circle are said to be coming from a common point. And we know that those two tangents are going to have the same length. And we have two radiuses here, that's OC and then what? OB. Therefore, this diagram is what? A kite. That is quadrilateral A is a kite. We know already from the previous question. Now, we know that a radius meets the tangent at the circumference of a circle, making an angle of 90 degrees. So we have 90 degrees here. We also have 90 degrees here. Okay. Therefore, since the sum of interior angle in the quadrilateral is 360 degrees, we have what? We already have 180. That is 90 plus 90. So we are left with what? A sum of what? 180 degrees to get our 360 degrees, which is the sum of interior angle in the quadrilateral. Therefore, 100 plus x should be able to give us what? 180 degrees. Therefore, we write 100 plus x gives us what? 180 degrees. Therefore, x equals what? 180 degrees minus 100. Which gives us what? 80. Therefore, x gives us what? 80 degrees. So, as it is normally when you get questions like this, you just have to analyze the problem, use the properties you know already know to assess the question. You don't straightforward try to get the variable at all costs. You just have to analyze the diagram, okay, and know what the diagram is trying to tell you. By using the properties, sometimes you can get the properties from plane geometry 1 and then plane geometry 2, which is the circuit theory, and then other properties of other quadrilaterals. Okay, so we know we are on question 18 now. We are on question 18. And we know from the previous question we've solved. You know from the previous question you saw that a radius meets a tangent at the circumference of a circle to give us 90 degrees. Okay, so this radius meets this tangent and then we have 90 degrees here. We also have 90 degrees here. So this whole angle is 90, this whole angle is 90. And we learned from the previous question that diagrams like this, since adjacent sides are equal, and two tangents, which are said to be coming from a common point, are going to be what? Equal. Therefore, what can we do? We know that length VA is the same as length what? CA. Okay. Therefore, these tangents are the same and these radiuses are the same. Therefore, since adjacent sides are equal, we have what? A kite. This quadrilateral, we have opposite angles being what? 90 degrees, 90 degrees here. Okay, so we already have our 180 degrees. So 120 plus this whole angle should give us what? Should give us 180 degrees. And what's that going to be? We know that 120 plus which angle gives us what? 180 degrees. It is simply what? 60 degrees. But since what? A kite has one of its diagonals bisecting the corner angles. We know that this diagonal OA bisects the 60 degrees we have here. Therefore, y is going to be 30 degrees. Bisect it completely. Therefore, y is going to be what? 30 degrees. Okay. Now, we are left with what? X. How can we get x? To get x, let us analyze this. This length is the same as what? AB. Therefore, we can say that it is forming what? A triangle ABC. Since it is forming triangle ABC, what kind of triangle is this? We know that since two of its sides are equal, that is AC and then AB, we know that it's an isosceles triangle. Therefore, two of its base angles will also be equal. Therefore, if you have the whole angle to be 60 degrees, you have the whole angle to be 60 degrees, then it means that when we deduct 60 degrees from 180, the rest should be shared among these angles. Since two of its base angles are going to be what? Equal. Therefore, when we deduct 60 from 180, we have 120. 120 divided by 2, because when we share them equally, 120 divided by 2 also gives us what? 60. So we have 60 degrees here, 60 degrees here. Initially, we didn't know it will become an equilateral triangle. Okay, we were assuming it is an isosceles triangle because we didn't know the angles we were going to get here. But after we have finished solving for x, we had 60 here, the whole angle here giving us 60, the whole angle here giving us 60. Therefore, it means that triangle ABC is an equilateral triangle but not an isosceles triangle. Okay, so we have x to be equal to 60 degrees. So whenever you are given questions like this, you have to look at the properties, the conditions surrounding the problem. Okay, you know you have a radius here, you have a tangent. What are the conditions of a tangent? When a tangent meets a radius, what does it mean? You have to look at all those things before you start solving your problem. Okay, so this is where we bring our question to an end. Now we are on question 19 and we have this diagram here. We've been given P, Q, and then T to find. Okay. Now guess which kind of triangle is RQT. Okay. We know from our previous questions we've been solving that when we have two tangents, okay, which are said to be coming from a common point, and they touch a particular circle, okay, two tangents of a circle, which are said to be coming from a common point, it means that those two tangents are what? Are going to be equal. So tangent RT is the same as what? Tangent what? They have what? Equal length. They have equal length. Therefore, this triangle RQT is going to be an isosceles triangle. Since it is an isosceles triangle, then we can say that two of its base angles are equal. Therefore, this angle is going to be equal to this angle. Therefore, Q is equal to 50 degrees. Okay. Now, how can we get P? Let's assume we have an imaginary chord. An imaginary chord joining PR. Since we have an imaginary chord here, we know that when the chord subtends an angle at the center of the circle, it is twice the angle that same chord subtends at the circumference of the circle. So if you have 146 here, then twice of P should give us 146. So we have 2P equals 146. And divide both sides by 2. We have what? 2, 7, 14, 2, 3, 6. So we have 73 degrees. So P is 73. Now, looking at this triangle, let's come back to this triangle. Triangle QRT, we have 50 degrees here and 50 degrees here. When we sum up the interior angles in the triangle, it gives us what? 180 degrees. Therefore, this one, this angle plus this angle gives us 100. So what are we left in order to get 180? We are left with what? 80 degrees. So it means that T here is also what? 80 degrees. So we were using the properties of circuit theory. Okay. When you get a question like this, you should tune your mind towards the properties you've been given. You shouldn't use anything at all. Okay, that's why you should know the properties to off head, so that you know which particular property you should use when the question is given to you. We know that this one is going to be a isosceles triangle because of the nature of the tangents. Okay, and then we know this property already. But when a chord subtends an angle at the center, it is twice the angle that same chord subtends at the circumference of the center. So having these things in mind, and then we also know the properties of what? An isosceles triangle. So all those properties you should know them often in order to be able to solve questions of this nature. Okay. So this brings us to our question 20, which says that we should find the variable x here at angle T1, B, T2. Okay. Now, in doing this, we have to examine the diagram first by drawing some imaginary lines and then assessing some of the straight lines we have here. Okay, we know that there are some two tangents, that is T1A and then T2A. Okay. All these tangents are what? Coming from a common point and they touch the same circle. Therefore, these two tangents are said to be what? Equal according to the diagram. Since they are equal, let us look at one thing. Let's assume there is a line from the tangent joining the center. Okay. Now, since this line joins what? The tangent from the center, we can say that this line is a radius and this line is also a radius. So it makes T1O, T2A a kite, because adjacent sides are what? Are equal. Adjacent sides. This side is equal to this side. This side is also equal to this side. And a radius meets a tangent at the circumference of circle, and it makes what? 90 degrees. Making it what? 90 degrees at the circumference of the circle. So we have 90 degrees here and then also 90 degrees. Okay. And we know that the sum of interior angle in the quadrilateral is 360. So already we have 1990, we already have 180. So the rest should give us what? 180 degrees. 60 plus what? Gives us 180 degrees. We know that 120 degrees plus 60 gives us what? 180 degrees. So when we add 120 plus 60, we get what? 180 degrees. Now, by the help of this one, then we can imagine that, or we can assume that, let's draw an imaginary line from T1 to touch T2. Now we have this imaginary line here serving as a chord. Okay. Now when a chord subtends an angle at the center of a circle, it is twice the angle it subtends at the circumference of a circle. So we know that 2 times this variable x we have here gives us the angle 120 we have here. Okay, so it's as simple as that. If you have twice of x equals what? 120. You divide both sides by 2. Gives us what? 60 degrees. So we were able to get x by drawing imaginary lines. We drew this. Okay, and then we also drew this. And then we also joined T1 to T2. Okay, getting a chord here, we knew that when the chord subtends an angle at the center of a circle, it is twice the angle it subtends at the circumference of a circle. And then we also knew that when 2 tangents are said to be coming from a common point and they are touching the same circle, those 2 tangents are equal. So when we were doing those analysis, we realized that this diagram, that is T1O, T2A, is going to be what? A kite. Therefore, we know that it is a quadrilateral. The sum of interior angle in the quadrilateral is what? 360. And when the radius meets what? a tangent at the circumference of the circle, we get what? 90 degrees. So we're having 90 degrees here, 90 degrees there. Meaning we already have our 180 degrees. The rest was what? 180 degrees what? Left. So we were already having 60 degrees here. What should be added onto 60 degrees for us to get what? 180 degrees. That is exactly what? 120 degrees. So we drew an imaginary line joining T1 to T2. And we use the property we've gotten, which says that when a chord subtends an angle at the center of a circle, it is twice the angle it subtends at the circumference of the circle. So 2 times x gives us 120, and it brought us to what? S equals what? 60 degrees. So when you get a question like this, that's how you should go by it. You have to analyze the diagrams, the conditions surrounding what the variable you've been told to find. So this is where we end our questions. Okay, so in case if you are facing any problems, you can message me on my WhatsApp line, which is 0274 390088. This is my WhatsApp line. In case if you are facing any difficulties with the explanation I gave, you can message me on this line and then we can discuss. Okay.